Okay, so let's talk about how we can combine two functions using basic operations like addition, subtraction, multiplication, and division. So suppose we have two functions f and g. So, and also let's assume that their domains overlap, meaning for some x values where both functions are defined. So, for those common x values, we can define following functions. So, sum of two functions. Simply, what we do is if you are asked to take the sum of two functions, we add the output of two functions. Then let's talk about difference of two functions. So in order to get the difference of two functions, what we do is we subtract the value of gx from f of x. To get the product of two functions, what we do is we multiply the two functions together, or we multiply the two outputs together. And to get the quotient of two functions, we divide the output of A by the output of g of x. But this happens only when g is not equals to 0, because division by 0 is undefined. So these operations allows us to build functions from existing ones. So now let's see some examples for all these functions. So let's start with this example. Okay, so here we are given two functions f of x and g of x. F of x is equals to 2x plus 1 and g of x is x squared plus 3. And then we are asked to take the sum, difference, product and quotient of these two functions. So, and also let's discuss the domain of each functions as well. So let's first of all let's take the sum of two functions, which means simply you have to add the two functions. You have to take f of x and then you have to add it to g of x. So what you have to do is f of x is equals to 2x plus 1 and g of x is equals to x squared plus 3. And then you have to simplify this. Simplifying an expression like this means you have to combine alike terms. So we have x squared over here. We don't have any other x squared terms. So I'm going to write it as it is. And then I'm going to combine there's no any other terms with x, so I'm going to write that as 2x, and then I have two constants. I'm going to add the two constants together, which is plus 4. So this function over here gives you the sum of f of x and g of x. Next, let's take the difference of these two functions, which means you're going to write f of x as it is, and then you're going to subtract g of x from f of x. So I'm using here brackets. That's really important. And then let's remove the brackets. So here we can remove the brackets here. And then in order to remove these two parentheses, you have to multiply each term by this minus 1. So if you multiply this minus 1 by x squared, you get negative x squared. And then if you multiply this negative 1 with this 3, you'll get a negative 3. And then once you remove your parentheses, you can simplify this. Again, if you simplify this means you have to combine alike terms. So these are the two terms without any other terms. So next I'm going to combine these two constants, which will give you a negative 2. So this expression will give you the difference of these two functions. Now let's take the product of these two functions. So I'm going to use a different color to get the product. So which means you have to multiply these two functions together. Okay, so you have to multiply 2x plus 1 by x squared plus 3. Okay, so now let's multiply these two terms. First of all, you have to multiply 2x by x squared, which will give you 2x cubed. And then you have to multiply 2x by 3, which will give you a 6x, and then you have to multiply 1 by x squared, you'll get a x squared, and then finally you have to multiply 1 by 3, which you'll have a 3. So now let's simplify this. To simplify, you have to combine alike terms. Here you will have x to the power 3, you have x squared, so you don't have any alike term, it's just the same expression. So this will give you the product of these two functions. So here I have used the distribution property. Next, let's take the quotient of these two functions. To get the quotient, again I'm going to use the blue. So which means the quotient means you have to divide f of x by g of x. F of x is 2x plus 1 and g of x is x squared plus 3. So you cannot simplify this further, so I'm going to leave this as it is. So next, let's talk about the domain of each functions. So all these outputs are polynomials, and for these three functions, they are polynomial, which means the domain will be all real numbers. And here also, if you consider the denominator for all the x values, here you will get a positive denominator. It doesn't matter which x value you plug over here, you'll always get a positive value, which means you cannot find any zeros for this denominator. So if you consider all these four functions, the domain will be all real numbers. So let me write that over here. So all four expressions, the domain is all real numbers. So we can represent all real numbers by this interval notation, or else you can write here all real numbers. Doesn't matter. Just you have to figure out the domain. Okay, so this is how you get the functions using this method. And next, let's move into the next example. So here also you're given two functions, f of x as 3x plus 2 and g of x as x squared plus 1. And then you're asked to take the sum, difference, product, and the quotient. Once you have those functions, you have to evaluate each function at x equals 2. So you have to follow the same procedure as we did in the previous example. So here, first of all, you have to add the two functions together. And if you add those two functions and if you simplify the expression, you'll get your answer as x squared plus 3x plus 3. And then to evaluate the sum of this at 2, what you have to do is you have to take this expression and you have to substitute 2 instead of x, and you have to simplify that. Once you simplify, you'll get your answer as 13. Okay, next, the difference of two functions. Again, I have did the same steps. Like I have taken the difference and I simplified it. And in order to evaluate this at 2, you have to plug 2 into the expression. And then once you simplify it, you'll get a 3. Okay, so now the product. In order to get the product, I multiplied 3x plus 2 by x squared plus 1. So here, once you multiply 3x by x squared, you'll get 3x cubed. And when you multiply 3x by 1, you'll get 3x. And when you multiply 2 by x squared, you'll get 2x squared. And when you multiply 2 by 1, you'll get 2. So this is distribution property. And then again, you cannot simplify this further. So this is the answer. And then in order to evaluate this at 2, you have to substitute 2 into this function. And once you do the simplification, you can get answer as 40. What you can do is you can use your calculator to get this answer. Okay, so next, the quotient. Again, it's very similar procedure. you divide 3x plus 2 by x squared plus 1, because f of x is in the top and g of x is in the down. And then you cannot simplify this further, so this is your quotient, and in order to evaluate this quotient at 2, you have to substitute 2 into x, and you have to simplify that, and once you simplify that, you'll get 8 over 5. So this is how you get sum, difference, product and quotient of two functions.